these tutorials where mathematics literacy begins. Alright, so today we'll be looking at what Math 102 analytic geometry and calculus, which is perpendicular distance of a point from a straight line or from a line segment. How we calculate for the distance from a point down to a straight line. How do we calculate the distance? So now, all right. So now let's see how do we calculate the perpendicular distance of a point from a line. Now, the perpendicular distance d from the point, let's say xy, to the line ax plus by plus c equals 0. So we want this point p xy to this line. How do we calculate for the distance? It's given by, let's see, it's given by d must be equal to the absolute value of ax1 plus by1 plus c, all divided by square root of a all squared plus b all squared, which is the same thing as plus or minus, which is the absolute, plus or minus ax1 plus by1 plus c, all divided by square root of a all squared plus b all squared. So now, this is a formula for calculating the perpendicular distance of a point from a line. Now, we want to see the proof. How do we came about this formula? So we'll be doing the proof now. I mean now, today now, right now, away. How to get the proof of this formula. So now, let's start the ball rolling. Let's start the ball rolling. All right, so let's begin. So we have the diagram on the board, the Cartesian plane or our OXY plane. So now we have the points P, x1, y1, then this is our line, ax plus by plus c equals 0. So we assume that our line is in this form, ax plus by plus c equals 0. Now we have a point, which means we have this line is a line. So it's a line segment joining this point D and this point P together, right? So how do we calculate for the distance? The D here. How do we calculate for the distance? Now watch here. Since we know the line segment of ax plus by plus c, we can express this in what? The slope intercept form, which is y equals mx plus c. You can express that in the slope intercept form, so that we get the gradient of this line. Okay? If you get the gradient of this line, now you take what? The negative reciprocal of that to get the gradient of this line. Listen to me very, very carefully. Now, I want to find for the distance. The distance from D to P for this line, right? How do we calculate for the distance from this point P to this line? And I'm saying that if you want to calculate, it's the same steps or it's the same thing to what I'm saying is that it's the same thing I'm saying that we'll use that to calculate for what, or we'll use that to prove our formula. Okay, so don't forget. Don't forget at all. So I said we know the equation of this line to be ax plus by plus c equals 0. Now, what do? We have to express this in the form y equals mx plus c so that we get our gradient from there. That's the slope intercept 4. We express that in our slope equation form so that we get the gradient of this line. When you get the gradient, then you take the negative reciprocal of the gradient obtained here to find for the gradient of this line dp. So if you get the gradient of this line dp, you use the gradient of this line dp And this point, because you don't know this point, you know this point. So this point is on the line. So you get the gradient of this line and this point on the line to find for what? The equation. To find for the equation of this line using the point and the gradient. So if you find for the equation of this line, now you know the equation of this line and the equation of this line. And they are meeting at what? Point T, right? So you can work out what, or you can solve it simultaneously to find for what x and y, which will produce this point what D. So if you solve it simultaneously and you get point D, now I know point D now, then I know point what? P. So if you know this thing, then use the magnitude or the length formula, which is square root of what? X2 minus x1 or squared plus y2 minus y1 or squared to find for what? The distance or the length or the magnitude or the modulus of length what? TP. So now this is how we do it as that. Okay. So that's what I've said. That's the proving. So we are coming to start how to prove or how we came by this formula. D equals what? The absolute of x1, ax1 plus by1 plus c all divided by square root of ax squared plus b all squared. Alright, so now let's start. So now we say that what? Let D denote the point of the perpendicular from P towards ax plus by plus c equals 0. So that's our D. It is perpendicular, right? So this line is perpendicular to this line, right? So you can see that line DP is perpendicular to this line ax plus by plus c equals 0. So now we first say that ax plus by plus c equals 0. So we can label it as what? Equation star 1, right? So now we can express this guy in the form y equals what? Mx plus c, right? So that our m denotes our gradient. So let's express that. So I get my by, which means we are making y the subject. So by equals what? Negative ax minus c. Then what do we do again? We have to divide both sides by what? B. Right. So I have by divided by b equals negative ax divided by b equals, sorry, minus c over b. Alright. So now we now have our y. We now have our y, which is equal to negative a over bx minus c over b. So now we've expressed this equation in this form, y equals mx plus c, which is the coefficient of x is what? M, that's the gradient. So I can say that the gradient m equals negative a over b, which is the gradient of this line. That's the gradient. So we can label that as what? Equation 1. You can label that as equation 1 here. You can label that as equation 1. So this is my gradient m1 for this gradient m1. So kindly watch it carefully. Kindly watch it carefully. Alright, so let's continue. So now we have our gradient 1, which is negative a over b. Now, we can take the reciprocal of this gradient, which is negative. Here is negative 2. Our reciprocal will be b over a, right? Will be b over a. Now, why are we doing that? Because they are what? Perpendicular. And we said that perpendicular, which is m1 times m2, their product, the gradient, the product of their gradient must be equal to negative 1, right? So I can say that if I have negative a over b, then definitely I'll get b over a, which means I'll get my negative 1. So that this guy cancels, this guy cancels, it will produce what? Negative 1. Because when I multiply, I will obtain negative 1. Then definitely I can say that what? My m2 is b over of this M2 to be B over A. This gradient is negative A over B, and this M2, that's a gradient. The second gradient is B over A. The second gradient is B over A, which is very simple and very, very trivial as well. All right, so now let's proceed. So I'll use my second gradient, which is B over A, and this point P, x1 by 1, to find for the equation of this line. To find for the equation of this line. So how do you find for the equation? So the equation of a line is given as y minus y1 equals n times the expression x minus x1. Right. So I'm finding for what? The equation using this point P, x1, y1, and the gradient, which is b over a. We are finding for the equation of this line dp. We are calculating for the equation of the line what's dp. So we have to use a point on the line and what's a slope, which is b over what? A. So now let's see. Why don't put anything inside? Y minus my y1 is the same thing as y1 equals m is what b over a times my x minus x1 is the same thing as x1. So we have it as that. We have it as that. So now let's continue. Let's continue. So now we can make y the subject here. I have y being equal to b over a x minus x1. Then we send this one. We add y1 to both sides so that we get y1 so that they cancel, we get 0 here. Alright, so I add y1 to both sides of the equation so that I get plus y1 here. So I have y equals b over a times my expression x minus x1 plus what? y1. Alright, so now let me clean this place so that you know that you won't be confused here. Alright, so now let's proceed. Let's proceed. So we have our y equals b over a times our expression x minus x1 plus y1. So we can label that as our star 2. We can label that our star 2. Our star 2. So this one is then as well. The equation, that's the equation of line dp. That's the equation of line dp. So don't forget. Now we have the equation of this line dp, and we know the equation of this line, which is ax plus by plus c equals 0. So how do we get this from d? Then we have to solve the two equations simultaneously. That's where the work comes in. So we have to solve them simultaneously. So how best can we solve them simultaneously? So I have my y equals b over a times x minus x1 plus what? y1. Then I also have my y, which is equal to negative a over b x minus c over what? b. So I can say that I can label this guy as okay. So therefore my line dp equals b over a x minus x1 plus y1. I can label it as what? Equation 2. So that we use this and the equation 1. We solve it simultaneously. Alright, so we solve equation 1 and 2 simultaneously. So we can see that solving equations 1 and 2 simultaneously. So we are solving equations 1 and 2 simultaneously. Now, so equation 1, then I have my equation 2. Okay, I have my equation 2. So don't forget this one is the same thing as y. So that's y equals b over ax minus x1 plus y1. So since y equals negative a over b x minus c over b, we cannot equate. When you equate, then that means you are going to find what? The coordinate of what? X. You are going to find for the coordinate So we are solving equations 1 and 2. We equate the y's. So our y, we have y equals negative a over b x minus c over b, which is our equation 1. Then we have y equals b over a times x minus x1 plus y1, which is equation 2. So we equate because they are the same. Y is here, y is here, so we equate. So when we equate, we get negative a over bx minus c over b, which is equal to b over a times x minus x1 plus y1. So that's how we proceed. All right, so let's continue. So we have this. So I said we are equating to find for what's the x coordinate. So we have to make x the subject here. So we make x the subject. So we make x the subject. So we have to make x the subject here. X the subject. So now, how else can we make x the subject? Our LCM will be what's AB. So we multiply through by AB. How many times? 1, 2, 3, then what? 4. So we get AB times negative A over BX, then minus AB times C over B, then which must be equal to AB times B over AB, then times our x minus x1 plus AB times y1. We have this AB times y1. So which is very simple and very, very trivial as well. All right, so let's proceed. So we can say that B cancels with B cancels B, A cancels A. So I have A times A, which is A squared, that's negative A squared x minus we have AC. So I have AC, which must be equal to B times B, we have what? B squared times x minus x1, then plus ABY1 plus ABY1. All right, so we are making x a subject. So I have negative A squared x minus AC equals, we expand the brackets, B squared x minus B squared x1 plus ABY1. So how can we make x a subject? So now, let's bring this, sorry, we are making x, not x1. We are making x the subject. So we can send this guy to the right hand side so that we get negative AC. Then we bring this, which is plus b squared x1, then minus ABY1, which must be equal to b squared x, then what? Plus a squared x. Right. So now this one we can rearrange it as b squared x1. We let the positive comes first, then minus let's say AC, or let's say minus ABY1, then minus AC equals. Now we want x, the subject, so we can factorize x out. So x out, leaving what? B squared plus a squared. So I have my b squared x1 minus ABY1 minus AC equals, I have x, which is multiplying b squared plus a squared, can also be written as well. B squared plus b squared. So what do? We have to divide each side by a squared plus b squared. So I have b squared x1 minus ABY1 minus AC divided by a squared plus b squared equals x multiplying a squared plus b squared divided by a squared plus b squared. So this one cancels. So I get my x, which is equal to b squared x1 minus ABY1 minus AC divided by a squared plus b squared. So this is our x coordinate. That's our x coordinate. All right. Now we have our x coordinates. Similarly, we want to obtain our y coordinates, right? So how best can we obtain our y coordinates? We have equation 1 and equation 2. You have to make x the subject here, then x the subject here, right? Then equate them, which means we are solving them simultaneously to look for what our y coordinates. So let's make x the subject here. So now I have y will equal to negative a over b, x minus c over b. I send this one to the left hand side and bring this one. So I get a over b, x equals negative y minus c over b. So we multiply through by what? B. That's the LCM. So I have b times a over b, x equals b times negative y minus b times c over b. So this one cancels, so I get ax equals negative b y, and this one too cancels, negative c. So we divide both sides by a. So I get x a negative b y divided by a negative c divided by a. I get my x equals negative b over a y minus c over a. Right. So I can label this one as equation 3. As equation 3. Then we have this equation 2. We make x the subject here. So I have my y being equal to b over a x minus x1 then plus y1, right? So I get my y equals b over ax minus b over ax1 plus y1. So now let's see. Let's see how best we can solve that. All right. So now we are making x the subject. Don't forget. So now our LCM is what? 8. We multiply 2 by 8. How many times? 1, 2, 3, 4. So I get a times y, we get what? AY, which might be equal to, when I multiply a by this, b over a, we can see that a cancels what? A, then we obtain what? Bx. So I have my bx. Then when I multiply a by this guy to get negative bx1, so I get negative bx1. Then plus a by this y1, I get plus ay1. Right. So don't forget, we are making x the subject. So we send this one, we send that. So I have ay plus bx1 minus ay1 equals bx. So now, how best can we solve that? So I get my ay divided by b. We are dividing through by b because we want x. Then plus bx1 divided by b minus ay1 divided by b equals bx divided by b. So that this one goes off. Then we get x equals a over by plus bx1. So this one too, it goes off, right? Alright, so this one goes off. I get my x minus 3y1. So I can label this one as equation 4. As equation 4. As equation 4. Alright, so let's see. So I have my what? A over by, then plus this will be my x1, then minus ay1 over b. Ay1 over ay1 over b. So let me clean this side, then let's proceed with the program. It's very, very simple and very, very trivial as well. Alright, so now we have our x. We have our x being equal to negative b over a, y1 minus c over a, which I said is equation 3. Then we have another x which is equal to a over by. Then we can say that negative a over by1, then let's say plus x1, which is equation 4. So we solve equation 3 and equation 4 simultaneously to obtain the coordinates of what? Y. We do have the coordinates of what? X already. So we obtain the coordinates of Y. So solving equation 3 and 4 simultaneously. So we have this. So we are solving it simultaneously. So now let's see. If you are solving that simultaneously, then we need to what? Equate them. So I get negative b over a y1 minus c over a equals a over by minus a over by1 plus x1. So because this is x equals that, x is also equal to that. So that, which means that we cannot equate the two equations. So we equate equation 3 to what? Equation 4. Since x is the same thing as that, x is also the same thing as that. So now we want what? Y. This time around we want y. We want y1. So we have to make y the subject. So what's the LCM? The LCM is what? AB. So we multiply here by AB. So I get AB times negative b over ay1 minus AB times c over a equals AB times a over by minus AB times a over by1 then plus AB times x1. So kindly watch it carefully. How many times? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that this one cancels, this one cancels, this one cancels, this one cancels. So we have b times negative by1, get what? Negative b squared y1 minus, we have bc equals, we have a times ay, get a squared y, then minus a times ay1, get a squared y1, then plus abx1. Right. So now, abx1, we want to make y the subject. Y the subject. Y the subject. So now let's see. We maintain this guy here. We maintain this guy here. We send this one's over there. Right. So now let's see how best we can solve them. Alright, so let's see. Our equation 3 is supposed to be what? Negative b over ay y. So negative b over ay. So it's supposed to be y. And here it's supposed to be y. Right. It's supposed to be y. So now I maintain this guy. Then I bring this guy because we want y. So I get negative bc. Then we bring this, which is plus a squared y1. Then minus abx1 equals I have my a squared y. So this one will be plus b squared y. So now, how best can we solve this? So I have my a squared y1 minus abx1 minus bc equals, we can factorize y out. So y out, a squared plus b squared. Right. So let's divide this side by what? Let's divide this side by a squared plus b squared equals y a squared plus b squared all over a squared plus b squared. So that this one they go away. Right. So that they go away. So now we can get our y. Alright, so we can get our y. Our y will equal to a squared y1 minus abx1 minus bc divided by a squared plus b squared. So that's our y. Alright, so now we have our x also to be b squared x1 minus aby1 minus ac divided by a squared plus b squared. So now, what we're doing, I believe you know what we're doing. We're solving what? Simultaneous equation. Because we had the equation for this line and the equation for this line. To obtain what? Point D. So you can say that point D is now what? Our x coordinates is b squared x1 minus ABY1 minus AC divided by A squared plus B squared. Then our y coordinate is A squared y1 minus AB x1 minus BC divided by A squared plus B squared. So we have our point D to be that. So this is our x coordinates, this is our y coordinates. So we have our x coordinates, then our y coordinates. So how best can we solve this? We can find for the distance if we find for what's the magnitude. So we want to find for the magnitude moving from point D to point P. What is the length between these 2 points? So now we have to find for what? The distance. The distance. So now let's proceed to find for the distance. Alright, so we have to find for the distance, which is the length of dp, or the length of p must be equal to square root of x2 minus x1 all squared plus y2 minus y1 all squared. So now we can take off the square root. So we square both sides, we take off what? The square root. So we square both sides to take off what? The square root. So I get my length of dp all squared equals, I have my x2 minus x1 all squared plus my y2 minus y1 all squared. Right. So how best can we solve this? Alright, so let's see. We have our x1, y1, so this one will be our x2, y2. So we substitute that into our formula. So we have our x2, which is that b squared x1 minus ab y1 minus ac all over a squared plus b squared. So that's our x2. Or better still, you can say that your x1 is your x2, then your x2 will be your x1, then your y1 will be your y2, then your y2 will be your y1. You can proceed as that. Alright, so let's use that. Let's use that. So I can say that this one is my x1, this one is my y1, and this one will be my x2 and y2. You can use x2, y2, x1, y1. It's the same thing. Since the distance from Kumasi to Accra, the same distance from Accra to Kumasi, it's the same kilometers. Alright, so now let's see. Our x2 is now what? X1, right? Minus our x1 is this, the whole of that. Don't forget. Let me bring our square bracket here. So minus, I bring my big bracket. So which is what? B squared x1 minus ABY1, then minus AC, all divided by A squared plus B squared, all squared. So we get it. Then plus our big bracket, we have our y2. Our y2 is what? y1. So y1 minus our bracket, which is a squared y1. So I get a squared y1 minus our ab x1 minus bc divided by a squared plus b squared. Then I have my all squared. So we have this. Very, very simple and very, very trivial as well. Alright, so now let's see. We have to deal with the brackets first, right? So this one is over 1, so we have to find for the LCM. The LCM will be what? A squared plus what? B squared. So I get my LCM, which is A squared plus what? B squared. So now 1 times A squared plus B squared, we still get what? A squared plus B squared, which will multiply that. So I have x1 multiplying A squared plus B squared. Then A squared plus B squared will go to A squared plus B squared 1 time. Now 1 will multiply the whole of that. Don't forget, negative is there. So negative 1 times B squared x1 minus AB y1 minus AC. Right. So our all squared. Our all squared. So we are taking this one. When we are done, we come and take this one. So I have we expand, we get a squared x1 plus b squared x1 minus b squared x1, then we get plus aby1, then plus ac all divided by a squared plus b squared. So then this a squared plus b squared all squared. Now you can see that this one takes away that. So I have my a squared x1, then plus aby1 plus ac all divided by a squared plus b squared all squared. So we have this. Alright. So we took this and we massaged it up to this point. So let's take this point when we are done with R. So better still the same thing. This is divided by 1 and the LCM is a squared plus b squared. So I can say that a squared plus b squared. 1 goes into a squared plus b squared, a squared plus b squared times. So it multiplies y1. So I get y1 times a squared plus b squared minus a squared plus b squared will go into a squared plus b squared 1. And this one multiplies the numerator. Don't forget the negative 1 times a squared y1 minus ab x1 minus bc all squared. So we multiply. So I have my a squared y1 plus b squared y1, then minus a squared y1 plus abx1, then plus bc, all divided by a squared plus b squared, all squared. So we can see that this guy cancels that, right? So we have b squared y1 minus, sorry, plus abx1 plus bc, all divided by a squared plus b squared, all squared. So now we have this and that. So we have to add them. We have to add them. Since they said we should add. So this one, we've simplified it and we have this. And this one too, we have that. So we have to add them. So now let's see how best we can go. So let's proceed. So the length of DP all squared must be equal to, I have this, which is that. So I have a squared x1 plus aby1 plus ac divided by a squared plus b squared all squared. Then plus our b squared y1 plus ab x1, then plus bc all divided by a squared plus b squared all squared. So we have this. We have this. So how best can we solve this, guys, here? So let's proceed. All right. So now we have the length of DP all squared, which can also be written as. Don't forget this square. We have A over PB all squared. It can be written as what? A squared over B squared. So we apply the same property here, right? So we apply that. So I get a squared x1 plus aby1 plus ac all squared divided by a squared plus b squared all squared plus b squared y1 plus abx1 plus bc all squared divided by a squared plus b squared all squared. So let's clean this off. All right. So Let's proceed. All right, so let's proceed. Our length of dp all squared must be equal to, now our LCM will go a squared plus b squared all squared, right? Because we are adding, that's additional fractions, our LCM is this. This one will go into itself 1. 1 multiplies that, we still get a squared x1 plus aby1 plus ac all squared plus the same thing. 1 time it multiplies, we get b squared y1 plus ab x1 plus bc all squared, right? So our length of dp all squared must be equal to, now we can factorize a out. So watch, we have to factorize a out. We get a x1, then plus by1, then plus c all squared, right? Don't forget. All right, so let's see. So, sorry for this square. So, A out, then AX1 plus BY1 plus C, right? So, I can bring my all square because this A is still inside the bracket. It's still inside the bracket. Then plus, you can factorize B out here, B out, then I get my B y1 plus our ax1 then plus our c all squared, right? All divided by a squared plus b squared all squared. So our length of dp all squared must be equal to, now don't forget, if I have ab all squared, mind you, is the same thing as a squared, b squared. But if you have a plus b all squared, it's never equal to a squared plus b squared. This one is wrong, right? Okay. So now let's proceed. All right. So now we can say that it's a squared. Then I have ax1 plus by1 plus c all squared. Then plus we have what? B squared. Then by1 plus ax1 plus c all squared divided by a squared plus b squared all squared. Right. So we have this. Now we can say that this and that, they are the same, right? Well, let's write it down again so that you see. So I have the length of dp all squared, which is equal to a squared times ax1 plus by1 plus c all squared plus our b squared times ax1 plus by1 plus c all squared divided by a squared plus b squared all squared. So this and that they are the same. So I take one and I get a squared plus b squared. It's more or less like factorization, right? So we are factorizing. So I get a squared plus b squared, a squared plus b squared. Then I have this and that they are the same. So I take one, ax1 plus by1 plus c all squared divided by a squared plus b squared all squared. Don't forget, this one takes away one of that. So we get the length of dp all squared, which is equal to ax1 plus by1 plus c all squared divided by a squared plus b squared. Right. So now, how best can we find for our length of dp? Then our length of dp, we have to what? Take the square root of both sides. So we take square root of both sides. So now we get square root of the length of dp all squared equals square root of ax1 plus by1 plus c all squared all over a squared plus b squared. Right. So our length of dp. So this one takes away that. So now, don't forget, if you have square root of 3 over 9, it's the same thing as square root of 3 over square root of 9, which this one will give me square root of 3 over 3. Square root of 9 is 3. Or we can say that plus or minus what? 3. Plus or minus 3. So now let's proceed. So I can also write it as square root of ax1 plus by1 plus c all squared divided by square root of a squared plus b squared. So the length of dp must be equal to, this one takes away that. So I have ax1 plus by1 plus c all over square root of a squared plus b squared. So we have this. So the length of dp is equal to ax1 plus b1 y plus c all divided by square root of a squared plus b squared. So watch it very carefully. Watch it very carefully. So now, therefore, we can say that the length of dp or the length of pd, therefore, the length of dp, which is the same thing as the length of pd, is equal to ax1 plus by1 plus c all divided by square root of a squared plus b squared, which is the same thing as well. You can say plus or minus ax1 plus by1 plus b divided by square root of a squared plus b squared. So I get my hence proved. Hence proved. It's very, very simple. Kindly follow the tutorials very, very well and you get the understanding. Very, very simple. Kindly go through again and you get the understanding. Massa tutorials, we say what? Where mathematics literacy begins. Thank you for subscribing. Thank you for watching. Thank you for